Hello everyone, you are welcome to Mathematics Tour. This is IGCSE Mathematics paper 4.2 written in October 2023. I have previously uploaded the variant 4.1. You can check my YouTube channel. The links to download the past paper solved in this video and the PDF solution are available in the description and the comment sections below this video. If you are seeing this channel for the first time or you are yet to subscribe to my channel, please kindly click on the subscribe button, as your subscription means a lot to me. Also, like, comment and share this video. Let's jump into the first question. Question 1. Translate triangle T by the vector -7, 1. Label the image K. So let's go to the triangle T. So the first thing we need to do is to name this. The first thing we need to do is to label this triangle. So this can be point P, this will be point Q, and this will be point R. And the given vector is -7 against 1. So that means the value of x is -7 and the value of y is 1. So from each of the points, we count 7 towards the left hand side and 1 upward. So let's start from point P. 1, 2, 3, 4, 5, 6, 7. Then let's go up once, 1. So point P prime will be point P prime will be here. So the same thing for point Q. 1, 2, 3, 4, 5, 6, and 7. So let's go up once. So point Q prime will be here. Then finally, we need to do the same thing for point R. 1, 2, 3, 4, 5, 6, 7. Then let's count 1 up, 1. So point R prime will be here. So of course, if you compare the object and the image, so for RQ, from R to Q, you have 2 steps. So from the image, we have 2 steps as well. Then from the object again, that is between P and Q, we have 1, 2, 3, 4. We have 4 steps. So let's go to the image. 1, 2, 3, 4. So this is okay. Then the last thing we need to do is to join the points together. So starting from P prime, so you can draw like this. Then you draw like this, and finally you join P prime to Q prime. So that will be the image, and we are asked to name this image K. So I'll put K here. We are done with the first instruction. Let's go to the next question. Describe fully the single transformation that maps triangle K onto triangle T. So that is K back to T. So it will also be translation, but the vector will be opposite of this now. So it will be translation, and the vector will be 7 against -1. That is, x is equals to 7 and y is equals to -1. So let's see. 1, 2, 3, 4, 5, 6, 7. You can see we counted towards the right hand side, so that means x is +7 and 1's down. Okay, that will be 1, that's -1. So we can easily go here. Let's write translation. Okay, so by the vector x equals to 7 and y is equals to, let's write this very well, x equals to 7 and y equals to -1. So that will be the vector. So part B, reflect triangle T in the line y equals to 4. So that's the mirror line. So we need to go to y equals to 4. So y equals to 4 is this line here. So you can draw this like this. Then we need to reflect each of these points to the other side. So let's start with point P. So from point P, let's count to the mirror line. 1, 2. Then the image will be 1, 2. So point P prime prime will be here. So we can call this P prime prime. Okay, then from Q again, let's count to the mirror line. Of course, we should have the same distance, and definitely it should be here. So this will be Q prime prime. Point R is on the mirror line, so it remains there. So it will just be here. So the next thing we need to do is to join the points together from P prime prime to Q prime prime. You have this. Oh, let's take that again. From P prime prime, let's draw to Q prime prime. Draw like this. Then also you can draw this one from here like this and join it to point R prime prime. And finally you join this to R prime prime. So this is the image of the reflection. And if you go back to the question, okay, so we are not asked to name the image by anything, so we are okay. Now let's go to the next question. That will be part C. Rotate triangle T through 90 degrees clockwise about 0, 0. So this is the center of rotation, this is angle of rotation, and this is the direction. So I'll put that into consideration. So we are moving clockwise. Let me write up here, clockwise, and 90 degrees, about 0, 0. That's the origin. So to do this, if you have your tracing paper, it is super easy. Otherwise, you have to make use of a ruler and a protractor, and that will make it easy for you as well. So I'm going to get my protractor. So this is my protractor here. Then I need to get a ruler. So this is my ruler here. So I'm going to make use of these two tools, and we show you how to rotate by using these two tools. And I'm going to do just only one for you, and I'll do the remaining ones offline. So the first thing you need to do is to draw a line from the center of rotation to each of the points. Okay, so let's start. Okay, let's pick this now. Let's adjust this a little bit. Okay, so we can draw a line from the center of rotation to point P. So from here we draw a line like this. So you need to draw carefully and make sure it is on the line. Okay, so let's see. I think this is not good enough, so let me redraw this. Yes, I think this is okay now. So the next thing you need to do is to pick your protractor. Then you rotate it. The center of the protractor should be on the center of rotation. So I can minimize this a little bit. So you put the center of the protractor at the center of the rotation. Then you also make sure that the line of the protractor is in line with the line that goes to point P. So you have to carefully set it like this. So I can scroll down a little bit for you to see it very well. So let me pick my ruler so I can bring it closer. So let's scroll down a little bit. Now, once the center of the protractor is on the center of rotation and the line on the protractor, okay, is also on the line that goes to point P, okay, so that means point P should be on 0 now, okay. So if we are rotating clockwise, so that is 90 degrees clockwise, okay, so we are going to count from 0. Currently P is at 0, so if you count 90 degrees, it should be somewhere here, okay, so it should be somewhere here. Let me put the point there, okay, but we need to know the length from the center of rotation to point P, so that is where we need to make use of this ruler. So I can reduce this ruler a little bit, okay, good. So let's put the ruler here and measure the distance from the center of rotation then to point P. Now from the center of rotation to point P is about 3.5 there, so we can easily take the protractor away from this point. Then we need to place the ruler, okay, to measure the direction. Now, of course, I know that this is the direction of 90 degrees. This particular point is the direction of the 90 degrees. So the ruler should be placed very well, okay, so that it will be in line with it. Then I can now measure the length, okay, so it is about 3.5, okay, so it will be this point here. So you can see this is 3.5 here, okay, so that is how you rotate each of the points. So I can name this point P prime prime prime, so that will be P prime prime prime. So I'm going to draw a line from the center of rotation to point Q, then measure 90 degrees by using the protractor and measure the length from point O, that's the origin, to point Q and draw just like what I did here. Also, I will draw a line from the origin to point R, then I will rotate the line by 90 degrees and also measure the distance between the center of rotation, which is the origin, and the point R. Then I will transfer it here. So I will join the 3 points together, and that will be the image of the rotation from the origin by 90 degrees clockwise. So I'm going to do the remaining 2 points offline, then I'll show you my results. So I have rotated the other 2 points and I have them here respectively, Q prime 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 and R prime 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 respectively. So the next thing you need to do is to connect these points together. So from point P to connect to Q prime 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 prime. Then let's take that again. So this is the image of the rotation of triangle T. So let's scroll down to see the next question. That will be question D, Roman figure 1. Enlarge triangle T by scale factor of negative half. Center 0, 0 and label the image P. So let's go up a little bit. So we can get rid of these twos. The scale factor is minus a half, and the center of enlargement is x equals to 0, y equals to 0. So what we need to do is to count from the center of enlargement to each of the points in triangle T, okay? So, and multiply by the scale factor and do the needful. Okay, so let's start with point P from the center of enlargement. So let's count the x and the y movements or steps. Okay, so we have 1, 2, 1, 2. So that means we have 2 by 2. So we need to multiply by the scale factor, that is times minus 1 over 2. Of course, this will give us a new vector that will be minus 1 minus 1. Okay, so that means from the center of enlargement we count 1 towards x and 1 in opposite direction of this. Okay, so for this we counted forward, so for this one we are going to count backward. So for this we counted up, and for this we're going to count downward. Okay, so or you can just follow the sign here. Minus 1, you go to the left hand side, then minus 1, you go down. So let's count once. 1, then 1. So the image of point P will be here. Then we can call this P prime 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 prime. Okay, so let's go to point Q. So from the center of enlargement, let's count to point Q. 1 2 3 4 5 6, then 1 2. So we have 6 against 2, so you multiply by the scale factor, which is minus a half. So this will give us negative 3 and negative 1. So from the center of enlargement, minus 3 is here, then minus 1 is here. So I'll put the point here. So this will be Q prime 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 prime, and the last one is point R. So let's count. That is 6. Then 1 2 3 4. So this is going to be 6 against 4. Okay, so let's multiply by the scale factor. That is minus half. So that will give us minus 3 against minus 2. So let's count from the center of enlargement. Minus 3 will be here, then minus 2 will be 1 and 2. So the point will be here. So this will be R prime 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 prime. So let's connect the 3 points together. That will be the image of the enlargement. So I have connected the 3 points together, and this is the image of the enlargement of triangle T. So we are asked to name this P. So we can put P here. Then let's go to the last question there. Describe fully the single transformation that maps triangle P onto triangle T. Okay, so just like the reverse of the translation, so this will also be enlargement. Okay, but now we are moving from P to T, so that means we need to get the opposite of minus 1 over 2. That is the inverse. So this is going to be enlargement from center of enlargement, which is 0 0, and the scale factor in this case will be the inverse of minus 1 over 2. So that is going to be 2 over minus 1, which is minus 2. So that will be the scale factor. So we can come here and still write enlargement. Okay, the enlargement by scale factor, that is negative 2. Okay, and center x equals to 0, y equals to 0. That is the origin. So I think we are done with question 1. So we can go to question 2. Question 2, Daisy records 50 homework marks. The table shows the results. We have the table here, as well as the we have the table with the homework mark and the frequency. Write down the range. So of course the range is equals to the biggest minus the smallest. So in this case the biggest number here is 20 and the smallest number here is 15. So you can easily do 20 subtract 15. So that means the range is equals to 5. Write down the mode the mode is the highest occurrence. So 17 occurs or appears 19 times. So therefore 17 is the mode. Roman figure 3, find the median. The median will be, okay, since we have 50 numbers here, or 50 marks, then we need to divide it by 2. That will be 25. Okay, so the median number has the position of 25, so that's the 25th number. Okay, so 15 is the first number, and the next 3 numbers are 16, so that will be 4. 1 plus 3, that is 4. So 4 add 19, that will be 23. So of course, the 25th number will be in this region here. So that means 18 is the median. So write 18 here. Then Roman figure 4, calculate the mean. So to get the mean, we need to find the product of these 2 rows. So I can call that, okay, if the homework mark is x, okay, so the frequency is f, so the product will be fx. So I can multiply 15 by 1, that will be 15. 16 by 3, that will be 48. 17 by 9, that will be 383. Sorry, 3, 2, 3. Then if you multiply 18 by 11, that will be 198. Then this will be 190, and this is 120. So then you need to add these together. That is 15 add 48, add 323, add 198, add 190, add 120. So that will give you 894. So I can easily scroll down a little bit. So the summation of fx will be equals to 894. Of course, the summation of the frequencies is 50. So the mean will be summation fx over summation f, and that will be 894 divided by 50, and the mean is approximately 17.9 to 3 significant figures. Then part B, the list shows Ed's score in 11 tests. Complete the stem and leaf diagram to show this information. So we have to order this from the smallest to the biggest, and the key is 2/5 represents 25. So to complete this, we'll put 8 here, that is 18. So this is gone. Okay, so the next one that we have 20, and it appears 2 times, 20, 20. So you can put 0 here and 0 here. So the next one is 21. We have 1, 2, and 3. So you can put 1 here, 1 here, and 1 here. And the next one is 22, just only 1. So we put 2 here. And finally, we have 25, which is also 1s. So we are done with the 20s. Then next we have 30, that is 0 here. Then we have 33, that is 3 here. And we have 34, we have 4 here. So this will be the stem and leaf diagram. Then find the median. So the median will be the middle number, since we have 11 numbers. So let's count 1, 2, 3, 4, 5 will be here. So let's count from the back. 1, 2, 3, 4, 5. Okay, so the median is 21. So we can easily put 21 here. Then find the interquartile range. So the interquartile range is Q3 minus Q1, that is the third quartile, subtract the first quartile. That will give us the interquartile range. So to get the third quartile. So you make use of this formula. Q3 equals to 3 over 4 into n plus 1. So this will give us the third quartile. And okay, let's key in the values. So it will be, this will be equals to 3 out of 4 into 11 plus 1. So this will be 12. 12 divided by 4, that will be 3. Then 3 divided by 3 times 3, that will be 9. So this is the third quartile is the 9th number, and if you check there, that's going to be 30. So let's count. So we have 1 2 3 4 5 6 7 8 9. So the 9th number there is 30. So that means Q3 is equals to 30. So we need to find the first quartile, that is Q1, and the formula is 1 out of 4 into n plus 1. So this will be equals to 1 out of 4. So n is 1, n is 11. 11 add 1, that will be 12. Okay. So 4 here 1, 4 here 3. So 3 times 1 is 3. So that means the first quartile is the third number. So that will be 1, 2, and 3. That will be 20. So Q1 equals to 20. Then we can now get the interquartile range. That will be 30 subtract 20, and that will be 10. So the interquartile range is 10. Let's go to the next question. That will be question 3. Question 3. The value of Priya's car decreases by 10% every year. The value today is $7,695. Calculate the value of the car after 1 year. So the percentage decrease is 10%. And the initial value is $7,695. So this means that at 100%, so the value is $7,695. So if it depreciates, okay, so that will be at 90%. Okay, so at 90%, what will be the value? So let's put x here. So if you cross multiply, then I'm solving for x, so that will be x will be equals to 7695 multiplied by 90, then divided by 100. So this will give you 6,925.5. Okay, so alternatively, you could firstly find the depreciation by doing 10 out of 100 multiplied by 7,695. That will give you excuse me, that will give you the depreciation, and it's going to be 769.5. that is the amount of the depreciation. Then you subtract it from 7,695 to get the current value. Okay, so it will be 6,925.5. so you can still use the same method and get the same answer. So let's go to Roman figure 2. Calculate the value of the car 1 year ago. So currently that is at 100%. The value of the car is $7,695. So a year ago, it means that the price will be higher because depreciation is yet to occur on it. So that means it's going to be 110%. You have to return it back. Okay, so what will be the value? It will be x. So you follow the same steps here. So you're going to have the value of x to be equals to 7695 multiplied by 110, then divided by 100, and this will give you $8,464.5. So alternatively, you can firstly get the depreciation by finding the amount of the depreciation, that is 10 out of 100 multiplied by 7,695. That will give you the amount of depreciation which we did earlier. Then you add it to this value and it will still give you $8,464.5. Let's go to part B. Ali invests $600 at a rate of 2% per year simple interest. Calculate the value of Ali's investment at the end of 5 years. Here the principal is 600 and the rate is 2%, which is the same thing as 0.02, and time t is equals to 5 years. So to calculate the value of Ali's investment at the end of 5 years, so that will be amount, it will be equals to the principal plus the interest. Okay, already we have the principal, which is 600. Now we need to get the interest. So the interest will be P times R times T. So if you do this, we have 600 times 0.02 times 5. So if you input this into your calculator, the interest will be $60. Now the amount will be principal, which is 600, add the interest, that will be 60. Then we have 660 as the amount. So this is going to be $660. So let's go to part C. Sarah invests 500 at a rate of R% per year compound interest. At the end of 12 years, the value of Sarah's investment is $601.35. Correct to the nearest cent. Find the value of R. So we know that A, that is the amount, equals to P into 1 plus R over N to the power of NT, where P is the principal, R is the rate, N is the number of times the interest is paid in a year, while T is the given number of years. So let's get in the values. We have 601.35, that's the amount, equals to the principal, that is $500, then into bracket 1 plus the rate is what we are looking for. So we can write the rate in percent is R out of 100. Okay, that's the rate is the same thing as R over 100, which is the same thing as 0.01 R. So that will be the rate. So I can put 0.01 R. So I don't need to put percent again because I have divided by 100 already. Then N is equals to 1 as interest is paid once in a year. Then to the power of the time is 12. Then multiply by N, which is 1. So this will give us 601.35 to be equals to 500 into 1 plus 0.01 R, then everything raised to the power of 12. Okay, so we can firstly divide both sides by 500 to get rid of the 500 by the right hand side. So that will give us 1.2027, then is equals to 1 plus 0.01 R to the power of 12. Okay, so we need to get the value of R. So what we can do, note this is raised to the power of 1 by default. Then let's divide the powers by 1 over 12. Then this one will be times 1 over 12 as well, multiplication, sorry. So this will cancel this, okay, and we'll be left with 1.2027. to be equals to 1 plus 0.01 r, then raised to the power of 1, which is the same as this. So the next thing, okay, sorry, we should have to the power of 1 out of 12 here. So if you take your calculator, so input this into your calculator, so you should get 1.0155 to be equals to 1 plus 0.01 r. So if you collect like times, so you're gonna have 1.0155 subtract 1 equals to 0.01 r. Let's scroll down a little bit. So this will give us 0.15, sorry, to give us 0.0. So let's correct that. So this will give us 0.0155 to be equals to 0.01 r. So let's divide both sides by 0.01. Divide this by 0.01. So this will cancel this, and if you input this into your calculator, you should get the value of r to be 1.55%. Okay, so that will be the value of r here. So you can just shift the decimal point backward there. 1, 2. Okay, so dividing by 0.01 is the same as multiplying by 100. So that will be 1, 2. That will be 1.55. So 1.55 percent. So that will be, okay, that will be the radius. So let's go to the next question. So that will be question, okay, that will be part D. The mass of a radioactive substance decreases exponentially at a rate of 3% each day. Find the overall percentage decrease at the end of 10 days. So here, the radius is given as 3%, which is the same thing as 0.03. Then the time t is 10 days. Okay, so using the formula for exponential decrease, so we have y equals to ab to the power of x. So where y is the new value, a is the initial value, b is the rate in this case, which is equals to 1 minus r. So comma, so let's say b is equals to 1 minus r because it is decreasing. Okay, and x is the time. Okay, so let's key in the values here. So this will give us y to be equals to a into bracket 1 minus r, 1 minus r, that's the value of b to the power of x. Okay, so now let's key in the parameters. Y equals to a into 1 minus 0.03 to the power of 10. So this will give us y to be equals to a into 0.97, okay, to the power of 10, and this will give us y to be equals to 0.7374a. okay, so now we need to find the overall percentage. Okay, so this is the new value. So the old value is a. Okay, that's the initial value. Initial value is a, okay, which is bigger than this. So that means we need to say that to get the percentage, the new value, which is a smaller one, over the initial value, which is a bigger one, then multiplied by 100%. So that will give us the overall percentage. So y is equals to this. Y is equals to 0.7374a, then over a is equals to a, then multiply by 100%. So this is a and not 9. So A, we cancel out A here. So if you multiply this, we're going to get 73.7%. So 73.7% to 3 significant figures. So let's go to part Roman figure 2. Find the number of whole days it takes until the mass of this substance is 1/2 of its original amount. Don't forget that the original amount is A, okay? So the new value will be y is equals to 1/2 of A. That will be the new value. So using the same formula, we have y equals to A into 1 minus r to the power of x. Okay, so y is 1/2 of A, then equals to A into 1 minus r is 1 minus 0.03. That will be 0.97, then to the power of x. So don't forget that is what we need to get now. It will be x now. So x is what we want to get, the time. Okay, so if you do this, we're going to have 1 out of 2a to be equals to a into 0.97x. So let's change it to t now for you to see that we are calculating t. So a, we cancel out a here. So we are left with 1/2 equals to 0.97 to the power of t. Okay, so we need to take log of both sides. So that means we're going to have from here now, let's draw an arrow. Okay, so we're going to have ln 1/2 to be equals to ln 0.97 to the power of t. So this is the same as ln 1/2 to be equals to t ln 0.97. So I can divide both sides by ln 0.97. So ln 0.97. So this will cancel out this. So we are left with t by the right hand side. And if you divide this by this, you will get 22.75. Okay, so which is that's approximated value. So sorry, let me remove this. So this will be approximately equals to this. Okay, then that means we have 22 whole days. Okay, because the 23rd is not complete. Okay, so we have t to be equals to 22. So let's scroll down here. So we have 22 whole days. So let's go to the next question. So that will be question 4. The diagram shows a sector of a circle that is made into a cone by joining OA to OB. The sector angle is x degrees and the radius of the sector is 7.5 centimeters. The base radius of the cone is 1.5 centimeters. Calculate the value of x. So what is obvious here is that the length of an arc of this sector will form the base of this cone. So that means we can say that theta, the length of an arc, which is theta over 360 times 2 pi r. So let's use uppercase R for the radius of the arc here. Then must be equals to the circumference of the base of the cone, which is given as 2 pi r. Let's use small letter r for the radius of the cone. So of course 2 pi, we cancel 2 pi here. So let's scroll down a little bit. That means we are left with theta over 360. So multiplied by r, then is equals to r here. So let's key in the values of these parameters. So theta is what we are looking for. We want to calculate the value of x here. Okay, so okay, look at it here. This is the angle x. So we need to calculate the angle there. So that means we're going to have x over 360 times the radius of the sector is 7.5. So that will be 7.5. Okay, then equals to the radius of the cone is 1.5. So if you do this, you will get 7.5. Okay, let me draw an arrow. So you see 7.5x over 360 equals to 1.5. That means x equals to 360 times 1.5, then divided by 7.5. So x will be equals to 66 degrees. We have 66 degrees here. So we have 66 degrees as the answer. So let's go to part B. The diagram shows a cylinder with radius 8 centimeters inside a sphere with radius 17 centimeters. Both ends of the cylinder touch the curved surface of the sphere. Show that the height of the cylinder is 30 centimeters. Okay, so let's say this is the radius of the cylinder. So let's draw this here, and this is given as 8 centimeters. We can put 8 here, and the radius of the sphere, can put it here. Okay, so let's draw one here to be like this. Okay, let's retake that. So let's retake it. So the radius will be, the radius of the cylinder will be from here to this spot here. Okay, so we can equally do the same thing up here. So this will be the radius, and then the height will be from here, okay, down to this spot here. Okay, so we can have it like this. Okay, so the radius of the sphere will be from here. Let's join it here. Okay, then we can do the same thing from here. So let's join it to this. Now we can put the values there. So if this is the center here, okay, so this will be 8 centimeters. Okay, so we can do this like this. Let's complete this. So this will be the center, and this will also be 8 centimeters. So this is the center of the sphere. Okay, so the radius is 17. So this is 17 centimeters, and of course this is also 17 centimeters. Okay, so this will be a right angle here, and this will also be a right angle. So the height of the cylinder will be h. Okay, but if this is the origin here for this, so from here to here I can say it is h1, that's the height. From here to here I can say is h2 for this second triangle. So the height will definitely be h1 plus h2. Okay, so from the first triangle, let's calculate the value of h1. So they are congruent. Okay, so that means they are similar. So I can say the height, okay, let's scroll down a little bit. I can say the height is equals to 2 into h1. Okay, as h1 is equals to h2. Okay, so using Pythagoras theorem, so that means h1 will be equals to 17 squared minus 8 squared. That is h1 squared. Okay, then I can say h1 equals to square root of 17 squared minus 8 squared. 17 squared minus 8 squared will give you 225. So if you take the square root, that will give you 15 centimeters. So that means the height h is equals to 2 into 15, and it is equals to 30 centimeters. So that has been shown. So let's go to the next question. So that will be Roman figure 2. Calculate the volume of the cylinder as a percentage of the sphere. So the first thing you need to do is to calculate the volume of the cylinder. So the volume of the cylinder, okay, VC equals to volume okay, of the cylinder. So that will be equals to pi r square h. So this will be equals to 3.14 times the radius is 8 centimeters squared times the height is 30 centimeters. Okay, so this will give us 6028.8 centimeter cube. Okay, so okay, you can partition this. The volume, okay, of the sphere, okay, equals to volume of sphere. So that will be equals to 4/3 pi r cube. That will be equals to 4/3 times 3.14 times the radius is 17. Okay, 17 to the power of 3. So if you do this, you're going to get 20,569.1 centimeter cube. Okay, so there is point here, so let me indicate it very well. Okay, now that you have this, you can now calculate the percentage now. So that will be 6. Okay, so I can demarcate this here. So let's do this like this so that it will not be mixing up. Okay, so that will be 6028.8, okay, divided by 20,569.1 times 100%. Okay, so that will give us 29.3%. So let's go to part C. The diagram shows a solid sphere with radius 6 centimeters inside a cube with side length 20 centimeters. The cube contains water to a depth of 15 centimeters. The sphere is removed. Calculate the new depth of water in the cube. So this is very simple. What you need to do is to calculate the volume of the water when the depth is 15 centimeters. Okay, then you also calculate the total the volume when it is full. Then you subtract it from there and you can get the depth. Okay, the new depth now. Okay, let me show you. So the first thing we need to calculate here, let's find the volume of the water when the depth is 15 centimeters. So we have 3 parameters here. Let me write it here. The length is equals to 20 centimeters. So the breadth, okay, is also 20 centimeters. And the height is 15 centimeters now because it is not full. Okay, so that means the volume of water when the depth is 15 centimeters, okay, so it will be equals to 20 times 20 times 15. So if you do this, this will give us 6,000 centimeter cube. Okay, then we need to find the volume of the sphere. So the volume, okay, you can say this is volume of water, okay, when the depth is 15. Okay, so volume of sphere will be equals to 4/3, okay, pi r cube. So if you key in the values, you have 4 out of 3 times 3.14 times the radius is 6 centimeters. That will be 6 to the power of 3. So if you do this, you should get the volume to be 904.32 centimeter cube. So the new volume now will be this, subtract this, okay, that will give us the new volume. That is when the sphere is removed, we are going to get the new volume. Okay, so the new volume of water will be equals to 6,000 minus 904.32. Okay, so that will give us 5095.68 centimeter cube. Now, okay, so what this means is that, okay, the volume when the sphere is removed, okay, is this. So we cannot have this 5095.68 to be equals to length times breadth times height. Okay, so we're going to have 5095.68 to be equals to the length remains 20 and the breadth remains 20. Okay, and we want to find the height, which is the new depth. So we have 5096.68 to be equals to 400 h, and h is now equals to 5096.68 divided by 400, and the height is equals to 12.7. So that means the new depth will be equals to 12.7 centimeters. So that is how to deal with that. So let's go to the next question. That will be question 5. In a shop, the cost of a fiction book is X dollars and the cost of a reference book is X plus $2. The cost of 11 fiction books is the same as the cost of 10 reference books. Find the value of X. Okay, so from the question, we know that let's denote the fiction by F, okay, and the price is X dollars, and let's denote the reference book by R, and the price is X plus $2. So from this statement, the cost of 11 fiction books, so that means we're going to have 11X, okay, is the same, okay, as the cost of 10 reference book. So that will be 10 into X plus 2. So let's expand the bracket. You have 11X to be equals to 10X plus 20. So if you collect like times, 11X subtract 10X equals to 20. X equals to 20. So the value of X is equals to $20. In another shop, the cost of a fiction book is Y dollars. The cost of a reference book is Y plus $2. Maria spends $95 on fiction books and $147 on reference books. She buys a total of 12 books. Show that 6y squared minus 109y minus 95 is equals to 0. So what you can do here, from this statement, she buys a total of 12 books, okay? So we need to get the number of books, the number of fiction books she bought at the shop, okay, as well as the number of reference books, okay? So then we add them to 12 because they add up to 12. So to do this, you just have to say that the number of excuse me, so the number of fiction books will be n times f, okay, plus n times r, okay, must be equals to 12. So this one will give us the number of fiction books she bought, while this will give us the number of reference books she bought, okay, and the two must add up to 12. So now the next thing I need to do is to calculate the number of fiction books she bought, okay. So she spent $95 on fiction books, so that means the number of books she bought will be 95 divided by the cost of 1, that is y, plus she also spent $147 on reference books, okay, so that will be 147 divided by the cost of 1, that will be y plus 2. So this will give us the number of reference books she bought, and it will be equals to 12. So this is how to deal with the question. Now we need to linearize. So by multiplying through by the product of y and y plus 2, this one is the same thing as over 1. So I will say y into y plus 2, then multiply by 95 over y. You have 95 over y. So this is how to linearize, plus y into y plus 2, then multiply by 147 over y plus 2, then equals to y into y plus 2 multiplied by 12. Okay, so y, we cancel out y here. We are left with 95 into y plus 2. Then here, y plus 2, we cancel out y plus 2. We are left with 147y, then equals to, if you expand this, so this will give us y times y, that is y squared, so times 12. So that will give us 12y squared. Y times 2, that will be 2y. 2y times 12, that will be 24y. So we can expand this bracket as well. 95 times y, that will be 95y, plus 95 times 2, that will be 190, then plus 147y equals to 12y squared plus 24y. So we can add this and this together as they are like terms. So this will be 242y, then plus 190 to be equals to 12y squared plus 24y. So let's scroll down a little bit. We can now rearrange this better. So let's transfer everything to the right hand side to have a quadratic equation. So this will be equals to, we already have 12y squared plus 24y by the right hand side, then subtract 242y, then minus 190, then set it to be equals to 0. Then if you do this, we are going to get this will be 6y. Okay, I think I'm skipping a step, so let's go back. So let's remove this. So we are going to have 12y squared, then minus 218y. If you subtract 242 from 24y, 242y from 24y, you get minus 218y, then minus 119. So we can factor out 2 because 2 can actually go in the 3 numbers. So that means we're going to have 0 to be equals to 6y squared, then minus 109y, then minus 95. Okay, so let's see. Okay, yes, we have shown this. That is correct. So let's go to Roman figure 2. Factorize 6y squared minus 109y minus 95. Okay, so we know that the product of this and this will give us I think 570 if you do this. Okay, then if you now divide 570 by 5, so you should get 114. So that means the factors of 570 that will add up to minus 109 are 5 and 114. Okay, so how do we arrange this now to get this? Sorry, instead of and here, you can put multiplication here. Okay, so that means we're going to have minus 114 plus 5y, and that will give us the middle expression here. So this will be 6y squared minus 114y plus 5y minus 95 equals to, okay, so no, it is not an equation, so we need to factorize. So if you factor out 6y here, you have 6y into, we have y left here minus 114 divided by 114y divided by 6y. That will give you 19. Okay, then plus 5 into y minus 95 divided by 5. That will also give you 19. Okay, so we can now have 6y add 5, okay, into y minus 19. So we have 6y plus 5, okay, into y minus 19. So this is how to factor it. Then Roman figure 3, we are to find the value of y. Okay, so from here you can say 6y plus 5 into y minus 19 should be equals to 0. So that implies that 6y add 5 should be equals to 0, or y minus 19 should be equals to 0. So from here it is obvious y is equals to 19 from this one, and here 6y is equals to negative 5. So y is equals to negative 5 divided by 6, and that will give us our answers. So y is equals to 19, okay, or negative 5 out of 6. So can leave the answer like that. So let's go to the next question. That will be question 6. The diagram shows a right-angled triangle. Find the value of W. So let's start with Pythagoras theorem. So we know that 2t plus 3 squared, that is the square on the hypotenuse, is equals to t squared plus 15 squared. If you expand this, that is 2t squared, that will be 4t squared. Then 2t times 3, that will be 6t times 2, that will be 12t. Okay, then add 3 squared, that will be 9. Okay, so that is the shortcut to this expansion. So because to t squared add 15 squared will give you this should be 5 squared, not 15 squared. Okay, so 5 squared will give you 25. Okay, so this will be 25. Okay, so we can now rearrange. Okay, that will be 4t squared minus t squared plus 12t plus 9 minus 25 equals to 0. So this will give us 3t squared, then plus 12t, then minus 16 equals to 0. So of course we cannot factorize this, so we make use of the quadratic formula method. So from there I can say that a is equals to 3, b is equals to 12, and c is equals to negative 16. Okay, so using the quadratic formula, so that means t will be equals to minus b plus or minus square root of b squared minus 4ac, then everything over 2a. So let's key in the values. T will be equals to negative 12 plus or minus square root of b squared, that will be 12 squared minus 4 into a is equals to 3 into c is equals to negative 16, then everything over 2 into 3. Okay, so if you scroll down a little bit again, so we have t to be equals to minus 12 plus or minus. If you simplify everything inside this radical, that is the square root, you're going to have the square root of, okay, 12 squared will give you 144, while the other expression will give you 192. so over 6. Okay, so we can simplify this further. T will be equals to negative 12 plus or minus square root of 144 add 192 will give you 336 over 2. Okay, so that means we're going to have t to be equals to minus 12 plus square root of 336. Okay, I think we can put the answer there. The square root of 336 is 18.3 out of, sorry, I wrote 2 here, this should be 6, so out of 6. Okay, then from there plus or minus, so of course we know that value of t will be equals to positive number, so that means a positive number, that means we don't need the negative one. So t, okay, let me divide this into 2. We know that t cannot be negative. Okay, t cannot be negative, so we are going to neglect only one, so that we will say t is equals to minus 12 add 18.3 over 6. So I will not do for minus 12 minus 18.3 over 6, okay, because t can never be negative. So t will be equals to 6.3 over 6, then t is equals to 1.05. So this is the value of t here. So if you scroll here, so we have t to be equals to 1.05. So we cannot make use of Pythagoras Socatua, okay, that is tan, okay, to get our answer here. So we can say that tan, let's scroll up, tan w, okay, equals to opposite is t, okay, that is 1.05, okay, 1.05 over 5, okay, so that will give us tan w, okay, so this will give us tan w to be equals to 0.21, so w is equals to tan inverse of 0.21, so which is equals to 11.9 degrees. So you have 11.9 degrees as the value of w. So we need to go to the next question. That will be question 7. The diagram shows a right-angled triangle PQR on horizontal ground. X is vertically above R and the angle of elevation of X from P is 21 degrees. XR equals to 2.8 meters and RQ equals to 7.1 meters. Calculate the angle of elevation of X from Q. So let's complete this diagram here. So from point P, let's draw a line here, and the angle of elevation of X from P is 21 degrees. Okay, also we need to complete this one from point Q. We draw another line up here. Okay, so this will be theta. Okay, this will be theta. So calculate the angle of elevation of X from Q. Okay, so from triangle Q RS, from this triangle here, so I can draw a sketch of it here. We have something like this. Okay, so this is like this, and we have another one like this. Okay, then we have another one like this. Okay, so this is point R here, and this is point X. We have point Q here. So this is the angle we want to calculate, and it is theta. Okay, then here is 2.8 and here is 7.1. So to calculate the angle here, we can actually make use of tan theta. Okay, so we can say tan theta equals to 2.8 over 7.1. then tan theta is equals to, this will give you 0.3944. So theta will be equals to tan inverse of 0.3944, and the value of theta will be 21.5 degrees. Okay, so that will be 21.5 degrees. You can work it down, you can write it here. Theta is equals to, okay, let's simply write the answer there, 21.5 degrees. So that is the answer there. So calculate PQ. So to calculate PQ, we start from triangle PRS here, because we need to find side PR. Then after that, we can now use Pythagoras theorem to find the length of PQ. So that will be pretty easy. We already know the value of RQ to be equals to 7.1. So once we find the value of PR, then we can use Pythagoras theorem to find PQ. Of course, PQ is the hypotenuse. So let's start from triangle PRQ. Okay, so we know, sorry, from triangle PRS rather, from triangle PRS. Okay, so we can get PR. So we know that tan 21 will be equals to the opposite. If you scroll up, is 2.8. Okay, so that will be 2.8, and the adjacent is PR. Okay, that's what we want to get. So from here, you can say PR is equals to 2.8 divided by tan 21. So if you do this directly from your calculator, so PR should be equals to 7.29. Okay, 7.29. So also you can say from triangle PRQ now. Okay, from triangle PRQ. Okay, so if you scroll up now, so we found PR to be equals to 7.29. Then we know that RQ is 7.1. So we can use Pythagoras theorem to get PQ, and that will be PQ squared will be equals to PR squared plus QR squared. So let's key in the values. So this will be 7.29 squared plus QR is 7.1, then squared. Okay, so this will give us 103.55. Okay, and the value of PQ will be square root of this, square root of 103.55, and PQ is equals to 10.2 centimeters. So 10.2 meters. So we can put the value here, 10.2 meters. So let's go to part B. Calculate the acute angle KML. So KML. So that will be this angle here. Okay, so we can put theta there. That's the angle we want to get. So we can use sine rule. That will be side 9.1 over sine 32 degrees will be equals to side 16.7 over sine theta. Okay, so you can easily cross multiply here. So you have 9.1 times sine theta, then equals to 16.7 times sine 32. Okay, so from there you can have let's say sine theta will be equals to 16.7 times sine 32 divided by 9.1. Let's scroll down a little bit. Okay, so sine theta will be equals to, if you do this, you should get 0.9725. That's what you should get. Then we can now take sine inverse of both sides. So theta will be equals to sine inverse of 0.9725, and that will give you 76.5 degrees. So theta is equals to 76.5 degrees. So that is the solution to that question. So let's go to the next question. That will be part C. The area of triangle ABC is 62.89 centimeters squared. Show that angle BAC, this angle here, is equals to 28.4 degrees. We can denote it by theta. Okay, correct to 1 decimal place. So we know that the area of the triangle, the formula is given as half side B. Okay, this will be side B, and this will be side C. Of course, this will be side A here. We don't need it. So it will be half times B times C, then sine A. That's the formula. So let's key in the parameters. The area is given as 62.89 centimeters squared. 1 half times the value of B is let's go 21.5, then multiplied by the value of C is 12.3, then sine A, which is theta. So this will give you I think we can cross multiply 2 multiplied by 62.89. That will give you 125.78 to be equals to then 21.5 multiplied by 12.3 sine theta. Also, you can do the product of this. So that will give you 125.78 to be equals to the product of these two will be 264.45 sine theta. Then you can now divide both sides by 264.45 divided by 264.45. So this will cancel out this. Then you are left with sine theta. This is what you are left with. Sine theta equals to 125.78 divided by 264.45. So this will give us sine theta to be equals to, it will give us 0.4756. Then if you take sine inverse of both sides, that means theta will be equals to sine inverse of 0.4756, and the value of theta will be equals to 28.4, correct to 1 decimal place. So we have shown that. Then we can now calculate BC. So to calculate BC here, we can make use of cosine rule. Okay, to calculate BC, we can use cosine rule. So the theta here is now, let's key in the value, 28.4. So using cosine rule, we can get BC, which is A. Okay, so I can say A squared equals to B squared plus C squared minus 2BC, then cos A. So if you key in the values, A squared will be equals to, B is equals to 12.3 squared plus C is equals to 21.5 squared minus 2 into 12.3 into 21.5, then cos 28.4. Okay, so if you do this, we are going to get A squared is equals to 148.73. So you can input all these values inside your into your calculator. then you get 148.73. Let me write this. It is 73, not 7 to the power of 3. Then now you can take square root of both sides. So the value of A will be square root of 148.73, and that will be equals to 12.2 centimeters. Okay, so that will be the value of length BC. AB is extended to a point D such that angle BDC is 90 degrees. Calculate BD. Okay, so if you come here to the diagram, so we know that this will be a right angle as shown here, and you have found the value of BC. A is now 12. Okay, it's now 12.2 now. So A is now 12.2 centimeters. Okay, so we can get the value of BD. Okay, but before we can get the value of BD, we need to find the value of CD. So by making use of the old diagram here, that is triangle ADC. Okay, so we can find CD. After that, we can find BD. So let's scroll down and finish it up. So you can say that, okay, let me have the sketch of the triangle here. So you have this line here, then you have another one here. Okay, then let's say you have another one here. So we have the triangle. Okay, so this is, we can extend this further, that is from here it goes beyond that. That's the extension to be somewhere around here. Let's redraw this properly. So now we have a better diagram. So this is point A, this is point B, we have point, this should be point C, this is point B, so we have point D here. Okay, and okay, we can, this is 90 degrees here, this angle is 28.4, this side is 21.5, so this is 12.3, and we want to get, okay, this BC is 12.2, so I just need to bring this closer so we can navigate through easily. So from triangle ADC, I want to find DC. So let's write here. So from triangle ADC, okay, so we know that sine 28.4 will be equals to opposite over hypotenuse. So we know that sine 28.4 equals to CD over 21.5. So we can cross multiply to get the value of CD. So CD will be equals to 21.5 sine 28.4. So CD will be equals to, if you put this into your calculator, CD should be 10.23 centimeters. So from triangle BDC up here now, okay, let's see. So from triangle BDC, we know the value of CD to be 10.23. Then we cannot use Pythagoras theorem to find the required length, which is BD. So from there, so let's write from triangle BDC, comma, so we have 12.2 squared, that's the hypotenuse, equals to 10.23 squared plus BD squared. Okay, so we have 12.2 squared minus 10.23 squared to be equals to BD squared. So from here, you can solve this directly. So you will get 4.19 equals to BD squared, and the square root of 4.19 will give you the value of BD, and BD is equals to 6.65 centimeters. That will be the value of BD. So 6.65. Okay, so let's go to the next question. That will be question 8. The diagram shows two fair dice. Dice A is numbered 1, 2, 2, 2, 3, 6. Dice B is numbered 2, 3, 3, 4, 4, 4. Dice A is rolled once. Write down the probability that it lands on the number 6. So the total is 6. So the probability that it lands on the number 6 will be equals to the number of 6 we have there, which is 1 out of the total, which is 6. So the probability is 1 out of 6. Let's scroll down to the next one. Dice A is rolled 150 times. Find the number of times it is expected to land on the number 6. Okay, since the probability of landing on 6 is 1 out of 6, then multiplied by the number of trials, that's 150 times. So if you do this, you should get 25 times. Okay, part B, dice A and dice B are each rolled once. Find the probability that the two numbers they land on have a total of 6. So here we need to prepare a table. So the first one will be we need to have the two dice. So for the first one, we need to have 1 here, 2, 2, then 3 and 6. Okay, so for the second die, we need to have 2, 3, 3, then 4, 4, and 4. So we try to combine them together. So here we're going to have 2, 1, or we have 2, 2, you have 2, 2, you have 2, 2, 2, 3, and 2, 6. So I can have 3, 1, 3, 1, 4, 1, then 4, 1, and 4, 1. Here we're going to have 3, 2, 3, 2, 4, 2, 4, 2, 4, 2. So let's fill up this. 3, 2, 3, 2, 4, 2, 4, 2, 4, 2. Then we have 3, 2, 3, 2, 4, 2, 4, 2, 4, 2. Then here we have 3, 3, 3, 3, 4, 3, 4, 3, 4, 3. And lastly, we have 3, 6, 3, 6, 4, 6, 4, 6, and finally 4, 6. So find the probability that the two numbers they land on have a sum of 6. So this will give us sum of 6. 3, 3 will give us a sum of 6. 3, 3 will give us a sum of 6. Then we have 4, 2 to be sum of 6. 4, 2 to give sum of 6. Then lastly 4, 2 to give sum of 6. So we can take the remaining ones below, this and this. This. We have this as well. We have this as well. Then we have the last two, this and this. Okay. So that means we have 11 numbers in total. So the total sum, the numbers that add up to 6 are 11. So we have 11 out of the total, which is 36. So if you count 1, 2, 3, 4, 5, 6, 6 columns, 1, 2, 3, 4, 5, 6, 6 rows, that would be 6 times 6, that would be 36. Okay, let's go to the Roman figure 2. Find the probability that when the two numbers they land on have a total of 6, both numbers are 3. So the two numbers are circled here, this and this. Okay, so the probability will be 2 out of 36, and that is 1 out of 18. So let's go to the next question. That will be that will be part C. Dice B is rolled n times. The probability that on the nth roll it first lands on a number 3 is 32 out of 729. Find the value of n. So here we're going to have many trials. So the trials will be n trials. Okay, so if it first lands on 3, so that means we're going to have the probability of 3. There will be 2 out of 6. Okay, that is dice B. Let's go from here. Dice B is okay, we have 3 to be 2, so and the total is 6. That will be 2 out of 6. Okay, so the probability that it lands on a 3 will be 2 out of 6. Okay, which is the same thing as 1 out of 3. So we have 1 out of 3 here. Okay, so out of the n trials, okay, it first lands on 3, and this is the probability. So that means it lands on the other ones, okay, which will be 1 minus probability of 1 over 3. So that will be the probability that it lands on other numbers. That will be 2 out of 3. Then raised to the power of n minus 1, because if this is we have n trials, so the probability that it lands on this is this raised to the power of 1. Okay, and this will be n minus 1. Okay, so for example, if you have 10 trials, so this will be the first one, and this will be 9 minus 1, it will be 9, so it will be 10 trials. Okay, so it will be equals to 32 out of 729. So we need to simplify this. Okay, so to do this, we can rewrite this one. This is indices. Okay, so we can write this as 1 over 3, okay, to the power of 1, then 2 over 3 to the power of n, then divided by 2 over 3 to the power of 1. Okay, so if you apply division law of indices, this will give you 2 over 3 to the power of n minus 1. I just have to return it back. Then it's equals to 32 out of 729. So here 3 will cancel 3. So we are left with 1 over 2 multiplied by 2 over 3 to the power of n, then equals to 32 over 729. So the next thing you could do here is to multiply both sides by 2 over 1. So if you do that, we're going to have okay, this will be 2 over 1 multiplied by this. Okay, let me take another line so that you can follow the solution very well. So let's scroll down a little bit. So we have 2 over 1 multiplied by 1 over 2, okay, multiplied by 2 over 3 to the power of n, then is equals to 2 over 1, okay, multiplied by 32 over 729. Okay, so this will cancel this. We are left with 2 out of 3 to the power of n here, then equals to, this will give us 64. 64 over 729. Now we can now take we can now divide the powers by n. That's one way, or we just express this to be in base of 2 and 3. So we can have 2 over 3 to the power of n, okay, to be equals to 64 will be 2 to the power of 6 over 729 will be 3 to the power of 6. So we can combine the power so that they both share one power. That will be 2 over 3 to the power of n to be equals to 2 over 3 to the power of 6. So this is initial equation. This base, we cancel this base. So n is equals to 6. So the value of n is equals to 6. So this is what we have here. So let's go to the next question. That will be question 9. The diagram shows a sketch of the graph of y equals to 4x to the power of 3 minus x to the power of 4. The graph crosses the x-axis at the origin, that's point O, and at the point A. The point B is a maximum point. Differentiate 4x cubed minus x to the power of 4. So if you differentiate this, d ds of this will be d dx, that is the differential when you differentiate this, the results will be 3 times 4, that is 12x to the power of 2, then minus 4x to the power of 3. So that will be your answer, 12x to the power of 2 minus 4x to the power of 3. Find part B, find the coordinates of point B. So to get the coordinates of B, since this is a maximum point, so we need to get the stationary point here. At stationary point, B is a stationary point, and at the stationary point, the y dx is equals to 0. So we've already differentiated the given function. So the y, the x, is equals to this answer here. We have 12x squared minus 4x cubed. So at stationary point, the y, the x is equals to 0. Then we can have 0 to be equals to 12x squared minus 4x to the power of 3. So here we can factor out 4x to the power of 2. Okay, so we have 0 equals to 4x to the power of 2. That means we have 3 minus x left here. So that implies that 3 minus x equals to 0. Okay, or 4x squared equals to 0. So this implies that x equals to 3. Okay, or x equals to 0. Okay, so 0 is a repeated root. Okay, so we have 3 solutions, 0, 0, and 3. Okay, so if you come back here, so it means this point here. Okay, so we need to get it, and I think this should be 3. So let's confirm that. Okay, so to test for the maximum point, we need to have the second derivative. Okay, so we can have the square y over the x squared. So that will be 2 times 12x. So that will give us 24x, then minus 3 times 4x. That will be 12x to the power of 2. So let's substitute the values of x here. So let's try this 3 first, because we're interested in that. So if x equals to 3, that means the y dx will be equals to 24 into 3 minus 12 into 3 to the power of 2. So this will give us 72 subtract 108. It means we are going to get the answer to be minus 36, so which is less than 0. So the implication of this is that this is decreasing. That means before it got to the stationary point, so let's go up here. So before it got here, it was increasing, okay, like this, going up, and after the stationary point, so it was decreasing. So this is negative and this is positive, okay, increasing. So since we got a negative value at x equals to 3 when we substituted into the square y and the x square, so that means it is decreasing and it was increasing. So we have confirmed that this is a maximum point. Okay, so we need to get the value of y when x equals to 3. Okay, so that is super easy. So let's plug in the value. So when y, the function is y is equals to 4x cubed, then minus x to the power of 4. So y will be equals to 4 into x equals to 3, then cube minus 3 to the power of 4. So if you do this, we are going to get the value of y to be equals to 27. That means x equals to 3 and y is equals to 27. So this will be the coordinate of B. So let's go to the next question. That will be part C. Find the gradient of the graph at point A. So the gradient of a graph is the first derivative, the y, the x, which is equals to 12x squared minus 4x cubed. So we need to get the value of x at point A. So if you scroll up at point A, the value of x should be greater than 3. Okay, so how can we get that? So at point A, y is equals to 0. Okay, so that means we can substitute 0 into this equation and we'll get the value of x. So let's scroll down and do that. So y is equals to 0 at point A. Okay, at point A. So that means y is equals to I think that should be 4x cubed, then minus x to the power of 4. So this is now 0 equals to 4x cubed minus x to the power of 4. So here x to the power of 4 is common, x to the power of 3 is common rather. So we can factor out x to the power of 3. We have x to the power of 3, then we'll be left with 4 minus x here. So this implies that, okay, it implies that 4 minus x equals to 0, and that implies that x equals to 4. So this is the value of x. Okay, that's at point A. Okay, at point A, so x is equals to 4. Then we can now get the gradient now by substituting x equals to 4 into this equation here. So that means the y, the x will be equals to 12 into 4 to the power of 2 minus 4 into 4 to the power of 3. So if you solve this, you will get the gradient to be minus 64. This will give you minus 64. So let's go to the next question. That will be question 10. Question 10. A, B, C, D, E, F is a regular hexagon. DF, DA, and DB are diagonals. Complete the following statement using 3 different triangles. Triangle DEF is congruent to triangle DCB. DEF is congruent to DCB. Triangle dash is congruent to triangle dash. Triangle DFA is congruent to triangle DAB. Part B. P and Q are points on the circle with center O. TP and TQ are tangents to the circle from the point T. Complete the following statements and reasons. In triangles OPT and OQT, OP is equals to OQ because each is a radius. Okay, that is very obvious. Radius, they are both radii. OT is common side. Yes, this is common side. Okay, so I can put the sign there, common side. Triangles OPT and OQT are congruent using the, okay, no, I jumped that. Angle OPT equals to angle OQT, because of what? Let's roll up. So this is 90 degrees. It is an angle between the radius and the tangent. This is also an angle between the radius and the tangent, so they are both 90 degrees. So we can say angle between a radius and a tangent. So triangles OPT and OQT are congruent using the criterion. The criterion will be similar size. See, this side and this side are equal, so that means the two triangles have equal sides. So that will be S. So this proves that the tangent TP and TQ are equal. Okay, they are equal. So let's go to the next question. That will be question 11. F of x equals to 1 minus 3x. G of x equals to x minus 1 to the power of 2. H of x equals to 3 over x, where x is not equals to 0. Find g of x. So g of x will be equals to, is given as x minus 1 to the power of 2. So g of 3 now will be equals to 3 minus 1 all squared. That will be 2 squared, and that will be 4. So that is g of 3. So part B, find f of minus f. Find f of x minus 2, giving your answer in the simplest form. So f of x is given as 1 minus 3x. Okay, so f of x minus 2 will be 1 minus 3 into x minus 2. Let's expand the bracket. We're going to have 1 minus 3x plus 6. So we're going to have 1 plus 6 minus 3x. That will be 7 minus 3x. So that will give us 7 minus 3x. 7 minus 3x. Part C, find f of x inverse. So let's repeat f of x. So f of x is given as 1 minus 3x. So in this case, let f of x be equals to y. Okay, so that means we're going to have y to be equals to 1 minus 3x. Then let's make x the subject of the formula. That means we're going to have y minus 1 to be equals to, okay, I think we can take the other way around. So 3x to the left hand side, it will be equals to 1 minus y. Okay, then we divide both sides by 3. X equals to 1 minus y, everything over 3. So now replace x with f of x inverse. That means we're going to have f of x inverse equals to 1 minus, then we'll replace y with x, then everything over 3. So the inverse, the f inverse will be 1 minus x, then everything over 3. So let's go to part D. G of f of x minus g of x times f of x should be equal to this expression. Okay, so we need to find the value of each of a, b, and c. Okay, so here what we need to do is to firstly find g f of x. So we know that f of x equals to 1 minus 3x, that is f of x. Then g of x is x minus 1 to the power of 2. Okay, if I'm not mistaken, let's see, g of x is x minus 1 to the power of 2. Yes, that's correct. So g of x equals to x minus 1 to the power of 2. So we can now get g f of x now to be equals to 1 minus 3x, okay, in bracket, minus 1, then everything to the power of 2, and this will give us 1 minus 3x, then minus 1, everything squared. Okay, so 1 we cancel, minus 1, so we are left with minus 3x squared. So this will be equals to 9x squared. That is the value of g f of x. Then we need to find the product of g of x and f of x. So g of x multiplied by f of x will be equals to 1 minus 3x, then multiplied by x minus 1 squared. Okay, you need to do this. So this will be equals to 1 minus 3x, okay, multiplied by the product of this will be x squared minus 1 times x, that's minus x, times 2, that is minus 2x, minus 1 squared is plus 1, that's the shortcut to read. So you need to expand this. If you expand this, you get the output should be 7x squared. Okay, you should get 7x squared minus 5x minus 3x cubed plus 1. If you expand and simplify very well, then we can now go to this now. So that means we can say that g f of x then minus g of x multiplied by f of x, so it should be equals to g f of x is 9x squared, then minus, so in bracket, 7x squared minus 5x minus 3x cubed plus 1. So let's expand the brackets by minus. Okay, so we'll have 9x squared minus 7x squared plus 5x plus 3x cubed, then minus 1. So if you rearrange and simplify, so we know that 9x squared minus 7x squared will give us 2x squared, then plus 5x plus 3x cubed minus 1. So let's rearrange this. We're going to get 3x cubed plus 2x squared plus 5x minus 1. Okay, so that means a is equals to, let's see, okay, with the expression we have, let's scroll up. So a is the coefficient of x squared, so that means a is equals to 2, b is equals to 5, and c is equals to minus 1. So a is equals to 2, b is equals to 5, and c is equals to negative 1. Okay, so let's go to the next question. So that will be this: find h of x minus f of x, giving your answer as a single fraction in its simplest form. Okay, so we know that h of x is giving us 3 over x, and f of x is giving us 1 minus 3x. 1 minus 3x. Then we can now do this. So h of x subtract f of x will be equals to 3 over x minus 1 minus 3x. So we can say like over 1. So the LCM is x. So we can have x here. So x divided by x, we have 1. 1 times 3, you have 3 minus x divided by 1, we have x. So x multiplied by 1 minus 3x. So let's expand the bracket. This will give us 3 minus x plus 3x squared over x. Okay, so if you rearrange, we're going to get 3x squared minus x plus 3 everything over x. So this is what we get here, 3x squared minus x plus 3 everything over x. So let's go to part F. H x to the power of n equals to 3x squared. Find the value of n. So in this case, what we need to do is to find h of x to the power of n. Okay, so we already know that h of x, let me repeat it again, is equals to 3 over x. Then h of x to the power of n will be equals to 3 over x to the power of n. Then this is equals to 3x squared. So we have 3 over x to the power of n to be equals to 3x to the power of 7. So what we can do here, 3 will cancel 3. We are left with 1 over, let's scroll down a little bit, 1 over x to the power of n to be equals to x to the power of 7. So we can write this as x to the power of negative n. Okay, to be equals to x to the power of 7. This is an initial equation. The base, we cancel the base. We have minus n to be equals to 7. That implies that n is equals to negative 7. So we have negative 7 here. Okay, so the next question will be question 12. Question 12. O is the origin with these coordinates. A is the point with this coordinate and B is the point with these coordinates. Write as column vectors. OB, okay, for OB, it's like we are moving from here, okay, to this place. So, and the direction is upward there. So that means we are moving like this along the x-axis and up along the y-axis. So OB will be 2 to the right and 5 up. That's the column vector. Then AB. So to get AB, let's draw a line here. Can have something like this. So draw from O to A like this in this direction. Then from A to B in this direction. It will be easier here. So we have OA like this and we have AB like this. So to get AB, that means you have to move from A to O. So this AB will be equals to AO. You move from A to O and from O to B plus OB. But we don't have AO, so you can change it to negative OA then plus OB. Okay, and that can be that will simply be OB minus OA. Okay, so I just have to show you how to derive this. You can easily say AB is equals to B minus A or OB minus OA. Okay, now we can do this. OB is equals to the column vector is 2, 5 like this. Okay, then let's divide this. Then minus OA. OA is 8, 1 as a column vector. So this will give us 2 minus 8. That will be minus 6. Then 5 minus 1 will give us 4. So we have negative 6 and then positive 4 here. So part B, find the equation of the line AB. So the line AB is this. okay, with their coordinates. Okay, so let me write their coordinates here. So A has the coordinates 8, 1, then B has the coordinates 2, 5. So that means you can say x1 is equals to 8, then y1 is equals to 1, then we can say x2 is equals to 2 and y2 is equals to 5. So the gradient will be m, okay, and it's giving us y2 minus y1 over x2 minus x1. So this will be equals to 5 minus 1 over 2 minus 8. So this will be equals to 4 out of negative 6. And this is the same thing as minus 2 over 3. So that is the gradient. Okay, so the line AB passes through A and B. So we can use any of the coordinates. So the equation will be, let's use point A. Y minus y1 equals to m into x minus x1. That will be y minus 1 to be equals to minus 2 over 3 into x minus x1. That will be 8. Okay, so if you expand this bracket, y minus 1 will be equals to minus 2 over 3x n plus 16 over 3. So from here, we can rearrange this very well. We have y to be equals to minus 2 over 3x plus 16 over 3 plus 1. So if you add these two together, you will get 19 over 3. So that means y will be equals to minus 2 over 3x plus 19 over 3. So that will be the equation. So y equals to minus 2 over 3x plus 19 over 3. So let's go to the next question. So that will be part C. Find the equation of the perpendicular bisector of AB. Okay, so already we have AB to be like this. Let's have a sketch here. So this is AB, and the perpendicular bisector will be a line like this. Okay, so we can draw it like this or simply here. Okay, so this is A. Already you know the coordinates of A. So that will be 2, 5, and this will be B. The coordinates will be 8, 1. So this is the perpendicular bisector. Okay, so we can call this one M. So we need to get the coordinates. Okay, so the coordinates will be x3, y3. And to get this, we're going to have do the midpoint. Okay, because the perpendicular bisector divides AB into two equal halves. So we'll say x3 will be equals to x1 plus x2 over 2. That will be equals to 8 plus 2 over 2. Okay, that will be 10 over 2, and that will be 5. So that means x3 is equals to 5 and comma. So let's find y3. So I think I can, let's see, y3. Okay, I can manage it here. Okay, I can manage here. So y3 will be equals to y1 plus y2 over 2. So this will be equals to 5 plus 1 over 2. This will be equals to 6 over 2, and this will be equals to 3. So it will be equals to 3. Okay, now I can now find the equation. Okay, so we know that the perpendicular bisector, okay, so I can name this one N here. Okay, so MN is perpendicular to AB. Okay, so that means their gradients will be inverse to one another. So the gradient of MN will be M2, okay, and the gradient of AB will be M1, and the product will be -1. So m2 will be the gradient of m1. I think we've already calculated that. We got minus 2 over 3. So minus 2 over 3 then equals to minus 1. So if you divide both sides by 3 over minus 2, so we're going to have m2 to be equals to minus 1. If you multiply both sides by 3 over minus 2 rather, so times 3 over minus 2. So minus will cancel minus here. So m2 equals to 3 over 2. Okay, so that's the gradient. Then the equation of the perpendicular bisector, okay, passes through point M with coordinates 5, 3. So we can now say that y minus y3 equals to m into x minus x3. Okay, that will be y minus 3 equals to m into x minus x3 is 5. Okay, so let's substitute the gradient. The gradient is 3 out of 2. So if you simplify this, you get the value of y to be equals to 3 over 2x minus 9 over 2. So y will be equals to 3. Okay, let's expand a bracket because we don't have space here again. So that is why I'm trying to manage this. So we can say that y minus 3 equals to 3 over 2x then minus 9 over 2. Then if you do this, sorry, I think I made a mistake. Okay, sorry, this is error. So this should be 5 here. So it will be 3s over 2 minus 3 times 5. So it should be 15 over 2. Okay, then you need to collect like times. So that means we're going to have y to be equals to 3 over 2 x, okay, minus 15 over 2 then plus 3. So if you simplify this, you get y to be equals to 3 over 2x then minus 9 over 2. Okay, so let's go to part D. The line AB meets the y-axis at P. Then the perpendicular bisector of AB meets the y-axis at Q. Find the length of PQ. So let's sketch this again. So this one will be, okay, let's draw this. So the y-axis will be something like this. Then the x-axis will be something like this. Okay, so we can now say that, okay, this is the y-axis and this is the x-axis. Okay, so point A should be somewhere around here. Okay, and point B should be somewhere around here. Okay, so we can join them together. Oh, I should have drawn the line first. Okay, so let's see. Okay, so this is good. Okay, and the perpendicular bisector should be somewhere around here like this. This is just a rough sketch. Let's say you have the perpendicular bisector here. Okay, so let's have it here. Okay, then this will be point A, this will be point B. So this is the midpoint here. Okay, so this will be point P. Okay, and this will be point Q. Okay, so P has the coordinates of x equals to 0, then y is equals to 4. Okay, we don't know. And here Q has the coordinates x equals to 0, then y is equals to y5. Okay, equation of line AB is y equals to minus 2 over 3x plus 19 over 3. So if you put the value of x to be equals to 0 when x equals to 0, okay, if you substitute here, you will get the value of y to be equals to 19 over 3. Of course, 19 over 3 is the intercept on y-axis. Okay, it is obvious here. Okay, so the same thing for the equation of perpendicular bisector of line AB. Okay, so we have y to be equals to, I think I can write here, so y to be equals to I think 3 over 2x, then minus 9 over 2. Okay, so it is obvious here. So this is the intercept on y-axis. It is minus 9 over 2, and if you substitute x to be equals to 0, you still get the same thing. So that means I know the value of the values of y4 and y5 respectively. So point P will be coordinates 0, 19 over 3. Okay, and Q has coordinates x equals to 0 and y equals to minus 9 over 2. Okay, so we cannot use this to find the distance between PQ. Okay, it will be equals to square root of the values are minus, we have 1 for point P, we have 0, 19 over 3. Okay, for point Q, that's point P, but for point Q we have 0, minus 19 over 2. So if you take this to be x1, y1, then x2, y2, so x2 minus x1 will be 0 squared, that will be 0. So plus y2 minus y1, that will be minus 9 over minus 19 over 2. Okay, then okay, this is minus 9 over 2 here, minus 9 over 2, so this should be minus 9 over 2. Okay, then plus minus 9 over 2, then minus, I'm doing y2 minus y1. Okay, minus y1, it will be 19 over 3. Okay, squared. Okay, so this is y2 minus y1 from here, that is minus 9 over 2, then minus 19 over 3 squared. So if you simplify this, so PQ will be equals to, you get square root of I think it will be 65 over 6 if you simplify this. Okay, so this will be the final answer, and PQ, when you divide, it will be 10.8 centimeters. So this is the end of the solution. So watch out for variant 2.2. Thanks for your time. Please don't forget to share this with your friends, and also subscribe if you are just seeing this channel for the first time, or if you are yet to subscribe, please kindly subscribe. Your subscription means a lot to me. Thank you. See you next time.